Hello everyone and welcome to the Complete Python course. This course is designed to teach you everything you need to know to master the Python programming language. Now I'm going to assume you're a beginner and you have no knowledge of Python, so I'm going to bring you through right from the beginning to more advanced sections. So this course is actually a combination of all of the videos I've made over the past year. Now if you want to figure out what section to jump to, or just figure out what's in this course, look in the description. There should be a bunch of different timestamps, so you can just skip through and go to the ones that you find most interesting. So with that being said, let's get right into it. Python is one of the most popular programming languages, and people use it to do cool things like automation, AI, and also build applications and websites. Some popular things made with Python are Instagram, Google, Spotify, Netflix, and Dropbox. In this section, I'm going to show you how to download Python on your computer. So the first thing I want you to do is open up your browser and head over to python.org. On this page, click on Downloads. Here, you can download the latest version of Python. So let's do that. So next, we need to install code editor. We need a code editor to write our code. So there are so many code editors out there, but the one I've chosen for this tutorial is Pycharm. So to get this, head over to jetbrains.com/Pycharm. So now let's go ahead and download Pycharm. So here on the download page, you can see two different versions. One of them is the professional edition, which you have to pay for, but the one we will be using in this tutorial is the community version. So let's download that. So every time you run Pycharm, you're going to see the main page. So when you're on that, you just click Create New Project. Now you can name your new project anything you want. Note that the first time you open Pycharm, you have to expand this project interpreter settings. Make sure the base interpreter is the latest version of Python. So an interpreter is basically a program that knows how to execute Python code. So when we're done all of that, we can click Create. So here in Pycharm, right-click your project's name and go to New Python File. Let's name that file app.py. So every Python file should have the Py extension. So now simply type print and parentheses. You can either use single quotes or double quotes. Then inside those quotes, write your name. Now with this piece of code, you can print your name on the terminal. To run this, you simply press Ctrl, Alt, and R. So, down below, you can see this little terminal window. So here, we can see the results or the output of our program. Now in the future, as you learn more Python, you'll be able to make applications that have a graphical user interface. That is a little bit complicated, so for now, we're going to use this little terminal window to see our results of our program. So as you can see, my name is printed on the terminal. Now, as you write code, this window might get in your way, so you can always resize it or even minimize it by using this icon here. So you've written your first Python code. In this section, you're going to learn about variables, which are one of the most fundamental concepts in programming. We use variables to temporarily store data in a computer's memory. Here's an example. Let's type price equals 20. When you want to print a variable, you simply write the name of the variable inside parentheses without any quotations. The price value here is a whole number without a decimal point. In programming, we refer to these numbers as integers. So an integer is a number without a decimal point. We can also write numbers with a decimal point. So here, let's write rating. Let's set it to 3.8. So we refer to these as floats. We have another type called Boolean. It can either be true or false. We can also set a variable to a string. For example, name equals John. So, you have learned how to print messages on the terminal. In this section, I'll teach you how to receive input from the user. So, print and input are functions that are built into Python. Let's say you want to ask the user for their name. This is how you do it. So, you write input, what is your name, between the quotes, then you store it in the name variable. Here's a little exercise for you. I want you to ask the user two questions, their name and their favorite color. Then, print a message like John likes blue. My solution is coming up next. So first, you start by defining a variable called name. Then, you set it to user input, and you ask the user for their name. Next, you make another variable called favorite color. Then you also set it to a user input and ask for their favorite color. And then you print name plus likes between quotations and favorite color. Now let's run our program and see what we get. Let's type our name and our favorite color. So it says the junior coder likes blue. Our program is working. Let's say you want to make a program to calculate someone's age. You make a variable called birth year, and then you set it to user input. Then you ask for their birth year. Then you make a new variable called age. Then you do some simple math. So 2020 minus their birth year. So now let's print the age variable and run our program. So let's give it our birth year. We got an error. So it says type error, unsupported operand type for integer and string. So what this is saying is that you can't subtract a string from an integer. Birth year is a string and 2020 is an integer. So you'll have to convert the birth year variable to an integer. And that's very easy. So far you've learned about two built-in functions. First is print and then the other one is input. We have a few more functions for converting values into different types. So we have int for converting a string into an integer. We also have float for converting a string to a number that has a decimal point. And we also have bool for converting a string into a Boolean value. So to fix this problem, we need to go back to the age variable and pass the birth year variable to the int function. This will change the birth year from a string to an integer. And now let's run our program again. Let's give it our birth year. And we get 14. Now here's a little exercise for you. I want you to write a program to ask the user for the weight in pounds, then convert it to kilograms and print it on the terminal. My solution is coming up next. Alright, let's use the input function to ask the user for the weight in pounds. Then let's store it in a variable called weight in lbs. Now we need to convert it into kilograms. That is very easy. So we define another variable, weight in kilograms, and then we set it to the integer value of the weight lbs times 0.45. Let's print weight kilogram on terminal and run our program. Let's give it 110 pounds. and we get about 50 kilograms. In this section, we're going to look at formatted strings in Python. Formatted strings are useful in situations where you want to dynamically generate some text using your variables. Let me show you. Let's say we have two variables, first name and last name. We set first to John and last to Smith. Let's say you want to print something like John Smith is a coder. To do that, we need to make a message variable, and let's set it to first plus some space plus last and plus is a coder between quotations. Now let's print message on the terminal and run our program. In the terminal, we can see John Smith is a coder, so our code is working. While this approach works, that's a lot of code for one sentence. So we use a formatted string to get the same output in far less code. Let me show you. So you prefix it with an F and then write first and last in curly braces since they're variables, and then write is a coder in the quotations. So now let's run our program again and we get the same result. In this section, we're going to be looking at a few useful functions when working with numbers. Let's start by defining a variable called x, and let's set it to 2.9. So we can round this number by using the built-in round function. So we write round and then we pass x. We have another useful built-in function called ABS, which stands for absolute. We give it a value and it will always return the positive representation of that value, even if that value is negative. So instead of passing x, we'll pass negative 2.9. Now let's print both of these on the terminal and run our program. So as you can see, the rounding is 3 and the ABS is 2.9. In this section, I'll talk to you guys about if statements in Python. If statements are extremely important in programming, and they allow us to build programs that can make decisions based on some conditions. So if some conditions are true, we're going to do certain things, otherwise we're going to do other things. Here's an example. Here in this text file, I have a few rules for our program. If it's a hot day, we want to tell the user that it's a hot day and drink plenty of water. Otherwise, if it's a cold day, we want to tell the user that it's a cold day and wear warm clothes. Otherwise, we want to tell the user it's a lovely day. So let me show you how to write a program that simulates these rules. Let's start by defining a variable called isHot. Let's set it to false. Next, we'll define another variable called isCold. We'll set that to true. Now, let's make a simple if statement. So if isHot, print it's a hot day, and also print drink plenty of water. Next, we'll write elif, which stands for else if. Is cold, print it is a cold day, and also print wear warm clothes. And else, print it is a lovely day. Now, let's run our program. We get it's a cold day, wear warm clothes. We get this result because is cold is set to true. If we change it to false and change is hot to true, we'll get it's a hot day, drink plenty of water. And if we set both of them to false, we'll get it's a lovely day. Here's an exercise for you. Imagine the price of a house is $1 million. If the buyer has good credit, they need to put down 10%. Otherwise, they need to put down 20%. Then print the down payment. My solution is coming up next. Let's start by making a variable called price. Then let's set it to 1 million. Next, let's make another Boolean variable called has good credit. Let's set it to true. Then, if has good credit, down payment equals 0.1 times the price. Else, down payment equals 0.2 times the price. Next, let's print down payment equals down payment variable. In this section, I'm going to talk to you guys about comparison operators in Python. We use comparison operators in situations where we want to compare a variable with a value. For example, if temperature is greater than 20, it's a hot day. Otherwise, if temperature is less than 5, it's a cold day. Otherwise, it's neither hot nor cold. So, to build these rules into our program, we need to use comparison operators. So, back in app.py, let's define a variable called temperature. Let's set it to 15. Next, let's make an if statement. So, if temperature is greater than 20, then let's print it's a hot day. If temperature is less than 5, let's print it's a cold day. Else, let's print it's neither hot nor cold. Now, let's run our program and see what we get. We get it's neither hot nor cold because temperature is between 20 and 5. But if we set it something more than 20, we'll get it's a hot day. And also if we set it something less than 5, we'll get it's a cold day. We have some more comparison operators in Python. So far we've learned about two comparison operators, the greater than and the less than. We also have the greater than or equal to, and the less than or equal to, and the equal to, and we also have the not equal to, which is an exclamation mark followed by an equal sign. This basically means if temperature is not equal to 20, then print it's a hot day. So now I have an exercise for you. I want you to write a program that follows these rules. So if username is less than 3 characters long, print username is too short. Otherwise, if it's more than 50 characters long, print username is too long. Otherwise, print username looks good. My solution is coming up next. Let's start off by making a variable called username. Let's set it to the user input, and let's ask the user to make their username. Next, let's make an if statement. So if len, and let's pass username, is less than 3, so the len that we wrote here is a built-in function. This particular built-in function finds the length of a given string. So in this case, it finds the length of the username variable. So we're typing if length of the username variable is less than 3, then we want to print username is too short. If len of username is greater than 50, then let's print username is too long. Else, let's print username looks good. Now let's run our program. So let's type in our username. So the junior coder should look good. But if we run it again and just write th, which is less than 3, we'll get username is too short. And if we run it again and we write something more than 50 characters long, we should get a message saying username is too long. In this section, we're going to talk about logical operators in Python. We use these operators in situations where we have more than one condition. Here's an example. If the temperature is more than 20 degrees and is sunny, let's print go outside and enjoy the weather. Otherwise, if the temperature is less than 5 or is raining, print stay indoors. So, let me show you how to make a program that simulates these rules. So back in app.py, let's define a few variables. Let's set temperature to 30, sunny to true, and raining to false. Now let's make an if statement. So if temperature is greater than 20 and sunny, then let's print go outside and enjoy the weather. If temperature is less than 5 or raining, then let's print stay inside. Now let's run our program and see what we get. We get go outside and enjoy the weather because temperature is more than 20 and sunny is set to true. But if we change one of those to something else, we'll get stay inside. Now if we change this back to 30 and change sunny to false and also change raining to true, we'll also get stay inside because the raining variable is equal to true. We have another logical operator which is not. So let's change the if statement to if temperature is greater than 20 and not sunny. So what this basically does is if temperature is greater than 20 and sunny equals false, then it will print go outside and enjoy the weather. So to recap, and basically means both, or means at least one, and not simply inverts the boolean. So if we set something to false, it means true. If we set it to true, it means false. So that's all for logical operators. So here's an exercise for you. In part 2 of this series, we made a program that converts someone's weight from pounds to kilograms. This time, we're going to change it up a bit. So the user can enter their weight in either kilograms or pounds, then you convert it to the other unit. My solution is coming up next. Let's start by making a variable called weight, and let's convert it to the integer value of the user input. Let's ask for the weight. Next, let's make another variable called unit, and let's set that to user input. And then ask for lbs or kg. Now, let's make an if statement. So if unit equals to L, then let's do converted equals weight times 0.45. Next, let's do print, and then let's prefix it with an F and do the converted variable kg. Let's do else converted equals weight divided by 0.45, and let's print converted lbs. Now let's run our program. So let's give it 110, and let's do L for lbs. We'll get about 50 kg. Now if we run it again and we do 50 and do K for kg, we'll get about 111. In this section, I'll show you how to use while loops in Python. We use while loops to execute a block of code multiple times, and they are often useful when building interactive programs and games. So let's get started with the basics. You write a while statement, and right after that, you type a condition followed by a colon. As long as this condition is true, the code that you write here will be repeatedly executed. So now let's build a simple game using a while loop. I want you to write a program to use a while loop to build a guessing game. My solution is coming up next. So let's start by making a variable called secret number. Let's set it to 9. Next, let's make another variable called tries. Let's set that to 0 for now. Next, let's make a while loop. So while tries is less than 3, we'll write the code here. So let's make a variable called guess. Then let's set it to integer value of input and then make a guess. Then let's do tries equals tries plus 1. So now let's make an if statement. So if guess is equal to secret number, then let's print u1 and type break, which basically ends the program. Now let's run our program. So let's guess the number wrong. So we'll do 3 tries and our program should end. Now if we run it again and guess the correct number, which is 9, we'll get u1. In this section, I'm going to talk to you guys about for loops in Python. In the last tutorial, you learned about while loops. You learned that we use while loops to execute a block of code multiple times. We have another kind of loop in Python that is a for loop. And we use that to iterate over items of a collection, such as a string, because a string is a sequence of characters, so it looks like a collection. So we can use a for loop to iterate over each item in a collection and do something with it. Here's an example. We type out for, then we define a variable. This is what we call a loop variable. In each iteration, this variable will hold one item. Let's call it item. In here we type a string like Python followed by a colon. So with this for loop we can iterate over this string, and in each iteration this item variable will hold one character at a time. So in the first iteration it will hold P, and then the second is Y, third is T, and so on. So here we are inside of our for block because of the indentation here. So whatever we type here will be executed in each iteration. For now we can simply print this item. So when you run this program, you can see that each character in our string is printed on a different line. Let's look at another example. In Python we can define lists using square brackets. So here we can define a list of names. For example, let's do John and Smith. So now let's run our program, and you can see that in each iteration we get a new name and print it on a new line. We can also loop over a list of numbers, for example 1, 2, 3, and 4. So when we run this we get a different number on each line. But what if we want to iterate over a large list of numbers? We don't want to type out a list of, let's say, 100 or 1,000 items. We don't want to type 5, 6, 7 all the way to 100. That's when we use the range function. So let me delete this. In Python we have a built-in function called range. We use it to create a range of numbers. So we give it a number, let's say 10, and when we run the program we see numbers from 0 all the way to 9. So it doesn't include 10. We can also work with a range of numbers here. So let's say we want to start from 5 and go all the way to 10. When we run this program, we see 5, 6, 7, 8, and 9. Also, this range function can optionally take a step. So after the 10, let's give it a step. So let's write 2. And now when we run our program, we get 5, 7, and 9. So it's skipping a number after each iteration. So this is the basics of using for loops in Python. Here's an exercise for you. I want you to write a program to calculate the total cost of all the items in a shopping cart. For example, let's say we have a list of 10, 20, and 30. Write a program to calculate the total of that. My solution is coming up next. So we start by making a list called prices, and let's set it to 10, 20, and 30. So as you learned, we use for loops to iterate over all the items in a collection. A collection can be a list, it can be a string, it can be a range object that is returned from the range function, it can be any kind of object that has multiple items. So in this example, we're going to use a for loop to iterate over the list of prices. So let's type out for item in the list of prices. By the way, this loop variable, you don't have to call it item, you can call it anything you want. So in this case, price will make more sense. So let's go back to the for block. Now in each iteration, this price will hold a value. So the first iteration will hold 10, the second will be 20, and the third will be 30. So we need to define another variable to calculate the total. We'll do that outside the for block. We'll do total equals 0 for now. Now in each iteration, we get the current price and add it to the total. So to do that, we can write total equals total plus price, or to simplify this, we can just do total plus equals price, which is the same expression in less code. So after our for loop, this total variable has the total of all the prices, so we can simply print that on terminal. Or we can use a formatted string to prefix it with an F, and then we'll add a label called total, then curly braces, and add the total variable. So now let's run our program. So the total of all the prices is 60. Now in this section, we're going to take a closer look at lists. So I'm going to define a list of names, and I'll set it to John, Bob, Sarah, and Mary. Now let's print the list on terminal. What we see on the terminal looks exactly like how we defined our list. So we have square brackets, and inside these square brackets we have our items. So John, Bob, Sarah, and Mary. Now we can access an individual element using an index. So here we type out square brackets and specify the index. So the index of the first object is 0. So when we run it, we get John. Now if you want to print out the third element in this list, its index is 2. So let's run that. We'll get Sarah. Now we can also pass a negative index here. So -1 refers to the last element in the list, which is Mary. If you pass -2, this will return the second item from the end of the list, which is Sarah. We can also use a colon to select a range of items. So if we type 2 and then a colon, this will return the items starting from the second index, which is Sarah, all the way to the end of the list. So if we run this program, we'll get 2 elements, Sarah and Mary. We can also specify an end index, so let's say 3. So this will return all the items from the second to the third index without including the third. So this will only return one object, which is Sarah. Now this also has default values, so if you leave out the end index, it will return every element starting from the second index. Now also, if you leave out the start index, this expression will return every object from the beginning to the end of the list. And by the way, these square brackets do not modify our original list. So here, let's set the start index back to 2, and then let's run our program. So we get Sarah and Mary. Then let's print the list again. So as you can see, it is not affected. We can also modify any of the elements in this list. Let's say we made a mistake and the first element shouldn't be spelled like that. So we access it by using an index that is names of 0. Then we set it to something new. So let's do JON. Now when we print our original list, we can see that it's updated. So these are the basics of lists. Here's an exercise for you. I want you to write a program to find the largest number in a list. My solution is coming up next. Let's start by making a list of numbers. Then let's set it to some random numbers, so 3, 6, 8, 10, and 2. Now, to find the largest number in this list, we need to define another variable, and let's call it max. This variable will hold the largest number in the numbers list. Now, initially, you want to assume that the first item in this list is the largest number, so we set max to the number of 0. Chances are our assumption is wrong. So we need to iterate over this list and get the largest number and compare it to max. If the largest number is greater than max, then we change max to that number. If it's not greater than max, we move on to the next number. So in this case, in the first iteration, it will check if the first number is greater than max. So is 3 greater than max? No. So it moves on to 6. Is 6 greater than max? Yes. So it changes max to 6. And it will do the same process with the other elements in this list. So here we need a for loop. So for number in numbers. Now we need to check if this number is greater than max. So if number is greater than max, then max equals the number. So now let's print max on the terminal and run our program. So we get 10. In this section, I'm going to talk to you guys about list methods or list functions. These are the operations that we can perform on a list. So let's define a list of numbers. Let's set it to some random numbers. So 5, 2, 1, and 7, and 4. Now, there are a number of things we can do with a list. We can add new items to it, we can remove existing items, we can check for the existence of an item. So when we type numbers dot, here you can see all of the functions or methods they can perform on this list. So let's write append, which basically adds a new item to the list, and let's pass 20. Then let's print the list on the terminal and run our program. As you can see, 20 is added at the end of this list. But what if you want to add a number somewhere in the middle or at the beginning? That's when you use the insert method. So instead of append, let's write numbers.insert. This method takes two values. So when you write open parenthesis, look at this tooltip above the method. It says that the first value that we need to pass here is an index. So let's say you want to add an item at the beginning of our list. So we set our index position to 0. Then the second value is the actual object that we want to add to this list. Let's say we want to add the number 10. When we run our program, you can see that the number 10 is placed at the beginning of the list and all the other numbers are pushed to the right. We can also remove an item, so we call remove and pass the item that we want to remove. So let's do 5. And when we run our program, you can see that 5 is removed from the list. If you want to remove all the items in the list, you can call the clear method. This method doesn't take any values. So when we print the list, you can see that it's empty. We also have another useful method called pop, and with this method we can remove the last item in a list. So when we call that, we can see that 4 is gone. Now if you want to check for the existence of an item in our list, you can call the index method. Then we pass a value here like 5, and this returns the index of the first occurrence of this item. So when we print this on the terminal, we can see that the first occurrence is at index 0, which is the first number. Now if you pass something that isn't in our list, like 50, you'll get an error, value error. It says 50 is not in the list. There's also another way to check for the existence of an item. We can use the in operator, so let me show you how. So we type 50 in numbers, then it gives us a Boolean value, so it says false. That means that 50 is not in our list. So here's an exercise for you. Write a program to remove the duplicates in a list. My solution is coming up next. Alright, let's say we have a list of numbers with a bunch of duplicates. So let's do 2, 3, 2, 4, 5, 3, 4, 6, and 1. So to remove the duplicates, we need to define another list. Let's call that uniques. And let's set it to an empty list. Then we need to iterate over our first list and get each item. And if we don't have that number in the uniques list, we'll add it to the list. So for number in numbers, now we need to check to see if that number is in the unique list. So if number not in uniques, uniques dot append number. And then outside our for loop, let's simply print uniques. So now when we run our program, we get 2, 3, 4, 6, and 1. So the duplicates are removed. In this section, I'm going to talk to you guys about another important structure in Python called tuple. Tuples are similar to lists, so we can use them to store a list of items. But unlike lists, we cannot modify them. We cannot add new items, we cannot remove any items. We say tuples are immutable. We cannot mutate or change them. Let me show you. So I'm going to start by defining a list of numbers. Let's set it to 1, 2, and 3. So we use square brackets to define lists and parentheses to define tuples. So let's change these to parentheses. Now we have a tuple. So if we write numbers dot, you can see that we don't have the append or insert method. So we cannot add new items to this tuple. We also don't have remove, clear, or pop, so we cannot remove any of these items. We only have two methods, count and index. We use count to count the number of occurrences of an item, and index to find the index of the first occurrence of an item. So we can only get information about a tuple, we cannot change it. So, similar to lists, we can access individual elements by using square brackets. So if you want to access the first element in a list, you do the index of 0. So let's print that on the terminal and run our program. So we get 1. But if you try to change the first item, you'll get an error. So let's try that. Let's try to change it to 10. So if we run our program, we get a type error. It says tuple object does not support item assignment. In this section, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, age, email, and more. Now each of these attributes have a value. For example, the name can be John Smith, the age can be 30, and their email can be john@gmail.com. So what we have here are a bunch of key value pairs. So in this example, our keys are name, age, and email, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary. So back in our program, I'm going to define a variable that is called customer, and let's set it to curly braces. With this curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30 and email to john@gmail.com. Now what matters here is that these keys should be unique. So if I add another key value pair here, let's set it to age 240, Pycharm will highlight the H key because we have duplicated that, and that's not allowed. So each key should be unique in a dictionary. So let's delete the duplicate key value pair. In this example, the keys are strings, but it can also be integers. We're going to look at that later. But the values can be anything. It can be strings, it can be integers, it can be booleans, it can be anything. Now we can access each item in this dictionary using square brackets. So we type customer square brackets and then specify a key like name, and this will return the value associated with this key. So let's print it on the terminal and have a look. So we get John Smith. Now what if you pass a key that doesn't exist? Let's say birth date. So when you run this program, you get an error. It says key error because we don't have a key called birth date. Also, if you spell name with let's say a capital N, you'll also get the same error because we don't have a key with the exact same sequence of characters. Now to fix this, we can use the get method. Let me show you. So instead of using the square brackets, you call customer.get and specify our key. Now if you use a key that doesn't exist here, it won't yell at us. For example, if you pass birth date, it simply returns the none value. None is an object that represents an absence of a value. So instead of getting a key error, we get none. Now we can also optionally supply a default value. For example, if the dictionary doesn't have this key, we can supply a default value. Let's say January 8, 1980. Let's run the program. Now instead of getting none, we get this default value. So this is how you can access a value associated with a key in a dictionary. We can also update these values. For example, before a print statement, we can write code like this. So customer of name, let's update the name to Jack Smith. Now this little warning is telling us that we could simply put Jack Smith here instead of defining it once and updating it. Don't worry about that, it doesn't really matter. Now with this line, if we print the name of the customer, we should get Jack Smith. Let me show you. So when we run our program, we get Jack Smith. We can also add a new key here. Let's set the birth date to some value like January 1st, 1980. And then we can print it here. So as you can see, we can easily add new key value pairs to a dictionary. So here's an exercise for you. Here we have this program that asks for a phone number. Let's type 1234. We type in digits, it will translate it to words. Take a look. It prints 1, 2, 3, 4. My solution is coming up next. Alright, so first we need to get the user's phone number. We call the input function and add a label like phone. We get that result and store it in this variable. Now let's say the user enters 1234. So we need to loop through the string, get each character, and translate it to a word. So what we need to use here is a dictionary, because a dictionary is a structure that allows us to map a key to a value. So let's define a dictionary and call it digits underline mapping. And in this dictionary, I'm gonna add a few key value pairs. 1, we map it to 1, 2 to 2, 3 to 3, and finally 4 to 4. Now technically we should add all the digits from 0 to 9, but for now 1 to 4 should be enough. So now we need to loop through the digits string. So for character in digits, we get each character and we use it to access each key value pair in our dictionary. So, digits underline mapping, we could use square brackets or call the get method. I would prefer to use the get method, so in case the user types a character that is not part of our dictionary, our program is not going to yell at them. So, we call the get method and pass this character as the key, and if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word, and we can add that word to an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this, and we should also add a space at the end, so the words are not close to each other. That's all we have to do. Now finally, let's print this output and run our program. So it asks us for our phone number. Let's type 1234. We get the words 1234. But if we write 1345, we'll get 134 followed by an exclamation mark. In this section, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We could type a message like I'm happy followed by a smiley face, and when we enter it, we can see that we get a smile emoji. And if we type I am sad followed by a sad face, it'll get translated to this sad emoji. So this is another application of using dictionaries. We have this dictionary that maps these characters into emojis. So let's go ahead and build this program. Back in our program, we start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message and we store it here. As you know, that is a string. Now we need to split this string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split, and we pass a string with 1 space as the separator. What this method does is that basically it goes to the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words, and then it will return a list. Let me show you. So let's store that in a variable called words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning, we'll get a list with 2 items. Each item is a string. Now, back to our program, we need to define a dictionary for mapping special characters to emojis. So we can call that mapping, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In this string, we want to add this emoji right here, followed by a comma. Then we'll do the sad face, and we'll map that to this sad emoji right here. So we have a list of words. Now we need to loop through this list, get each word, and potentially map it to an emoji. So we can write a for loop for word in words. Now I want to go to our dictionary and see if we have an item with this word as the key. If we have an item with that key, then we'll get this value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we will use the get method to supply a default value. So we want to get an item with a key word, and if we don't have an item with that key, we simply use that word as a default value. Now similar to the last exercise, we need an output variable. So let's define that here. Output, set it to an empty string. Now back to line 11, we get the return value of the get method and add it to our output variable. So output plus equals whatever you get from the get method. And finally, we need to append a space at the end. So let's print the output. and run our program. I'm gonna type I am happy followed by a happy face, and we'll get this emoji. And if I write I am sad with a sad face, we'll get the sad emoji. So as you can see, dictionaries have a lot of use cases and real applications. Here's the solution from the last section where we created an emoji converter. So far we've been writing all our code here in app.py. But as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you've learned about the built-in functions in Python, like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large complex programs, we should break up our code into smaller reusable chunks, which we call functions, to better organize our code. And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, we're going to potentially need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start by typing def, that is a reserved keyword, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. That name can be anything, but in this example, we'll name it greetUser. When you're naming your functions, always use lowercase letters, and if there are multiple words, separate them by using underlines, and always use meaningful and descriptive names. So here we're defining a function called greetUser. After that, we need to add parentheses followed by a colon. So let's do that. Now you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now any code that we write here will belong to this function. So I'm gonna move these 2 lines, these 2 print statements inside of our function. So we can simply press tab. That will simply indent them. Also, let's remove this extra line break. That is better. So these 2 lines are now part of our greetUser function. So whenever we call this function, these 2 lines will be executed. Now let's move the indentation. So here we are outside our function. Let's do a print statement and print start. After that, let's call our function, so greetUser. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. Now if you hover your mouse over it, this tooltip is telling us that you should add 2 blank lines after defining a function. This is coming from PEP 8, which is a document that defines the best practices for formatting our code. So to make Pycharm happy, we'll add another line break. So whenever we define a function, we need to add 2 line breaks after the definition. So now let's run our program and see what happens. Alright, so we get 4 messages on the terminal. First, we get the start message. Then we get the messages coming from our greet function. So hi there and welcome. And finally, we see the finish message. In this section, I'm going to teach you guys how to handle errors in your Python programs. So let's start by writing a small program to get the user's age from the terminal. So we call the input function and add a label here like age. This returns a string, so we need to pass it to the int function and store the result in a variable called age. Now let's print age to make sure everything is working. Run our program. We type 20 and 20 is printed here, so it's working. Now look at the exit code for this program. Exit code 0 means that our program terminated successfully. There were no errors. But what if we run this program And instead of entering a numerical value, we enter something like ASD. We get a value error with this message, invalid literal for int with base 10. What this is basically saying is that this string, ASD, does not contain a valid whole number that can be converted to an integer. Now look at the exit code of this program. Exit code 1 means that our program crashed. So 0 always means success, and anything but 0 means crash. Now as a good Python programmer, you should fix these situations. You don't want to let the entire program crash just because the user entered an invalid value. So instead of letting the program crash, you should handle the situation and print a proper error message. So that's what I'm going to show you in this section. Now before going any further, look at the type of error we got here, value error. So remember this, we're going to get back to this shortly. Now, how can we handle these errors? In Python, we have a construct called try except. We use that to handle errors. Let me show you how it works. So, on the top, we type try, followed by a colon. Now, as you know, we're defining a code block. So, I'm going to move these two lines inside of our try block. So, press tab here. Now, these two lines are part of our try block. So, after try, we type except. Then we type the type of the error that our program may encounter. That is value error. Then we add a colon, and in this block, we can define what should happen if our program encounters an error of type value error. In this case, we want to print a proper error message. So print invalid value. Now in programming terms, we refer to this type of error as an exception. So an exception is a kind of error that crashes our program. So if the user enters an invalid value, this line of code, line 2, will raise an exception, and on line 4, we'll catch it and print this error message so our program will no longer crash. Let me show you. So let's go ahead and run this. Age 20, everything works just like it was before. And the exit code is 0. Let's rerun this program and enter ASD. So we get this proper error message, invalid value, and once again the exit code is 0. So that means our program completed successfully. In this section, I'm going to talk to you guys about comments in Python. We use comments to add notes or comments to our Python programs. For example, here I'm going to make a print statement. So hi there. Now, before that, I can add a comment using a hash sign. And then whatever I type here, it's going to get ignored. It's not going to get executed. Let me show you. So, let's run this program. Look, we only see this message, hi there. So with this comment, we can explain something about our code. We can use them as reminders to fix things or clean things up, or we can use it to communicate with other developers reading our code. These are good use cases for comments. We can also have comments over multiple lines, so we can simply add comments. Each line should start with a new hash sign. Now, one thing you need to avoid when using comments is explaining what the code does. So here's an example of a bad comment. Let me just delete these two lines. And with this comment, I'm gonna say print hi there. Why is this a bad comment? Because it's telling me the obvious. It's obvious that the next line is gonna print hi there. So use comments to explain whys and hows, not whats. If you have made certain assumptions, you can use comments to explain those assumptions. Or you can use them to add notes to remind yourself or other developers to do something in the code. In this section, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming, and they're not specific to Python. In fact, a lot of other programming languages support classes too. We use classes to define new types. For example, so far you've learned about the basic types in Python, like numbers, strings, and booleans. These are the basic or simple types in Python. You also learned about a couple of complex types, like lists and dictionaries. While these types are extremely useful, they can't always be used to model complex concepts. For example, think of a concept of a point. A point is not a boolean, it's not a list, nor a dictionary. It's a different type of thing. So we can use classes to define real types to model complex concepts. Now in this section, I'm going to show you how to define a new type called point, and this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers 1, 2, 3. You know that here, when we type dot, we can access to the functions or methods available for lists. Now similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword, and right after that we give our class a name. Now look at the naming convention I've used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our functions and variables. For variables and functions, we always use lowercase letters, and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class only has a single word. If we had multiple words, let's say email client, look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So, back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the methods or functions that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parenthesis, Pycharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's just print move on the terminal. Now let's define another method like draw. So define draw, and in this method, let's just print draw on the terminal. Now let's remove the indentation. We are done with the definition of our point class, so we need to add 2 line breaks. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. The class basically defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we can have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods, and they're more of an advanced topic, so we're not going to be taking a look at them in this series. So now let's call the draw method of our point object and run our program, so you can see draw is printed on the terminal. Now apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. Once again, we type out the name of our class and call it like a function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because point2 does not have an attribute called x. So each object is a different instance of our point class. You have learned how to make new types using classes. Now there's a tiny problem in this implementation. We can create a point object without an x or y coordinate. Let me show you. So point, we create this object here, and before we set point.x, let's print point.x and run our program. We get this attribute error that you saw in the last tutorial. So point object does not have an attribute called x. This is the problem we have here. It is possible to have a point object without an x or y coordinate. And that doesn't really make sense, because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates like 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function. $_init. So init is short for initialize. And this is the method or function that gets called when we create a new point object. Now, when you press enter, Pycharm will automatically add self in parentheses. We're going to come back to this shortly. Now, right after self, we want to add two extra parameters, x and y. So let's type out x and y. And then, in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this: self.x equals x and self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we're referencing using this variable. So earlier we typed point.x equals 10. With this code, we set the x attribute to 10. Now what we have in the constructor is exactly the same. We're using self to reference the current object, then we set the x attribute to the x argument passed in this function. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. So now let's remove line 14. So we create a point object with these values and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program so x is updated. Alright, here's an exercise for you. I want you to define a new type called person. This person object should have a name attribute as well as a talk method. This is a very easy exercise, so you can probably get it done in a couple of minutes. My solution is coming up next. Alright, so first we start with a class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case the only word, is uppercase. Now, in this class, we define all the methods that we need. Currently, we only have one method, that is a talk method. So, define talk. Pycharm automatically adds self. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add 2 line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to a person. We can call John.talk. Let's run the program. So we get this message, beautiful. But our person object should have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is $_init_. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object, so we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9, and when creating the person object, we pass a name, let's say John Smith. Now, let's print john.name and run our program. There you go. So John Smith is printed on the terminal. So this is all you had to do as part of this exercise. But let's try to make this program a little bit more interesting. Instead of printing this boring talk message here, let's print, "Hi, I am John Smith." So we can use a formatted string with a message like, "Hi, I am." Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter. And this should be the very first parameter of every method. So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10 where we print john.name and simply call john.talk. Let's run our program. "Hi, I am John Smith." Now we can create another person object. Let's say Bob is a new person called Bob Smith. Then we say bob.talk and run our program. We get a different message. "Hi, I'm Bob Smith." So each object is a different instance of our person class. In this section, I'm going to talk to you guys about inheritance in Python. Inheritance is a mechanism for reusing code, and once again, it's not limited to Python. Most languages that support classes also support inheritance. So let me show you how it works. Let's say we have this dog class with a simple walk method. In this method, we're simply printing the walk message on the terminal. Now, let's say in a real program, instead of just one line of code here, we're going to have 10 lines of code. Now, what if in the future we want to define another class, let's say cat? We want to add this walk method there as well. We'll have to repeat all that code in this new class. This is bad because we have repeated or duplicated our code. In programming, we have a principle called DRY, which is short for don't repeat yourself. And here's the reason. Let's say sometime in the future we discover a problem with a walk method. If we have repeated or duplicated this method in many other places, then we'll have to come back and fix that problem in every single place you have duplicated that code. So that's why in programming, we should not define something twice. So how can we solve this problem? Well, there are different approaches. One approach, which is easier to understand for beginners, is inheritance. And here is how it works. We define a new class called mammal and move the walk method right there. Then we'll have the dog and the cat classes inherit that method from the mammal class. So on the top, we define a new class. Let's call it mammal. Then we need to move the walk method there. So we select it and cut it using Command and X on Mac or Control and X on Windows. Then paste it in the mammal class. Now we want our dog class to inherit that method from the mammal class. So right after the class name, we add parentheses and then type out the name of the parent class. In this case, mammal. That's all we had to do. So with this, the dog class will inherit all the methods defined in the mammal class. Now there's a tiny problem here. If you look at line 9, there is a red underline here. The reason this is happening is because Python doesn't like an empty class. So right now, our dog class is empty. It doesn't have any methods. We either need to add methods specific to dogs, or just to make Python happy, we can use the pass statement. And that basically means nothing. We're telling Python interpreter to pass this line. But with this, we won't have an empty class. So the dog class is now inheriting the walk method from the mammal class. We need to apply the same change to the cat class. So we'll have cat inherit from mammal and then use the pass statement. With these changes, we can now create either a dog or a cat object. Let's say dog1. We set it to a dog object. And when we type dot, look, we have the walk method that is defined in the mammal class. We can easily call it. Let's run our program. There you go, we see the walk message on the terminal. So both the dog and the cat class are inheriting every method that is defined in the mammal class. Now here we can add methods specific to dogs. For example, we can define a method called bark and then print bark. Now we don't need the pass statement because we already defined one method in our dog class. So now when we type dog1 dot, look, we have two methods. One is the walk method that we inherited and the bark method that we just defined in the dog class. So these are the basics of inheritance in Python. In this section, I'm going to talk to you guys about modules in Python. A module in Python is basically a file with some Python code, and we use modules to organize our code into multiple files. So instead of writing all our code in app.py, we want to break up our code into multiple files which we call modules. With this, we'll have the ability to reuse our code. For example, here in app.py, I've defined two functions. One is for when the weather is hot, and one is when it's cold. Now we can take these two functions that we defined and put them in a module. Then we'll have the ability to import that module to any program that needs these functions. So let's create a new file by right-clicking our project and going to new Python file. Let's call that functions.py. Then let's go back to app.py and cut all of this code and paste it in the functions module. A module is used to contain all the related functions and classes. Now let's import the functions module into app.py, and that is very easy. So we type out import and then the name of the module without the extension, so we don't write .py. Now we can access the functions in this module by using the dot operator. So we have two functions right now, is cold and is hot. So we can easily call one of these functions and run our program. Now there's also another way for importing modules. So instead of importing the entire module, we can import specific functions. So to do that, we can type from, then we add the name of our module, in this case it's functions, import. Now here, when you press Ctrl and space, you can see all the functions defined in this module. So here, we can type one of these functions. With this, we can directly call this function without using the dot operator. Compare what we have on line 4 and what we have on line 6. So, to recap, we use modules to better organize our code. Instead of writing all the code in one file, we break up our code into multiple files, which we call modules. In this section, I'm going to talk to you guys about packages in Python. Packages are another way to organize our code. So currently we only have one file in our project, but a real project can contain hundreds or even thousands of files. So we can organize related modules inside of a package. So a package is a container for multiple files. So in this section, I'm going to show you how to create and use packages in Python. Here in our project panel, right-click our project and add a new directory. Let's call this directory time. So we're going to create a package called time, and in this package we're going to have all the modules for working with time. So let's go ahead and create this. Now here we have an empty directory. In order to convert this to a package, we need to add a special file in it. So right-click this directory and add a new Python file. Call that file $_init_. This is a special convention in Python. When Python interpreter sees a file with this name, it converts this directory into a package. We also have a shortcut for that in Pycharm. So if you delete this directory, let's start again. Once again, right-click the project, go to new, but instead of creating a new directory, we can create a new Python package. Let's call our package time, As you can see, Pycharm automatically creates this file for us, so we don't need to manually create it. Now, in this package, let's add a new module. So create new Python file. Let's call it calculations. Now in this module, we want to add a function for calculating minutes. So define calculate underline minutes. So in this block, we simply print minutes. Now let's say we want to import this calculations module into app.py. So currently, this calculations module is part of our time package. So we can't import it directly. We have to start from the e-commerce package. So back to app.py. There are two ways to import this module. We can import the entire module, or we can import one of its functions or classes. So let me show you both ways. Let's start off by importing the entire module. Import. Now what's the name of our package? It is time. So time.calculations. So instead of typing import calculations, you type import time.calculations. We have to prefix it with the name of its package. Now, to access any of the functions and classes in this module, we'll have to type out time.calculations. And there you go. Now we can access the calculate minutes function. So when we run our program, we see this message printed on the terminal. However, with this approach, every time you want to call one of its functions, we'll have to prefix it with time.calculations. So when working with packages, we often use the second way to import using the from statement. So we can type from time.calculations import calculate minutes. Now we don't have to prefix this function with time.calculations. So our code is a little bit shorter. But what if you want to use multiple functions in this calculations module? We can either import them all here, so calculate minutes, comma, let's say calculate hours, or we can import the entire module and access all the functions and classes in that module. So to import the entire module, we type out from time, so we remove .calculations, then we do import calculations. So now we can access all the functions and classes defined here using the dot operator. So calculations dot, there you go, calculate minutes. So these are the basics of using packages in Python. In this section, I'm going to talk to you guys about the built-in modules in Python. So Python comes with a standard library that contains several modules for common tasks. So we don't have to code all of the functionalities from start. Let me show you where you can find the standard library. So open up your browser and search for Python 3 module index. So the first page here is for Python module index and it's for Python 3. So let's open that. So these are all the modules built into Python. For example, we have modules for working with date and time. Right now, you don't need to learn the whole list. As you build more programs, you'll get more familiar with the modules here. So in this section, I'm going to show you how to use one of the built-in modules for generating random values. So on the top, let's import the random module. Now because random is a built-in module, we don't need to have a file here called random.py. So Python interpreter knows that random is a built-in module, so it knows where to find it. So let's use this module to generate some random values. So when we import this module, we'll have this object, random, so we can use the dot operator to access its functions. One method that is very useful here is the random method, and every time we call it, it will generate a random value between 0 and 1. So here we can create a for loop. Let's say for I in range 3. So this for loop, we can execute this code 3 times. Now let's indent this. And finally, let's print the result on the terminal. When we run our program, we can see that in each iteration, we get a random value between 0 and 1. Now what if we want a random value, let's say between 10 and 20? Well, there's another method here, randint. We pass 2 arguments here to specify a range. So in this case, let's give it 10 and 20. So when we run our program, we get 3 integers between 10 and 20. If we run our program one more time, we get different values. We also have another useful method for randomly picking an item from a list. Let's say we have a list of names and we want to randomly pick a leader. Let me show you how to do that. So, we define the list of names. Let's call them members. Let's set that list to John, Mary, and Bob. Now, we can call the random.choice function and pass our members list. This method randomly picks an item from this list and returns it, so we can store the result in a new variable and then we'll print that variable. Let's run our program. So the leader is Mary. If we run our program again, we'll get a different one, so Bob, and if we run it again, we get Bob again. So you got the point. So the random module is very useful and you can use it for many different things. So here's a very cool exercise for you. I want you to make a program to flip a coin. So every time we run this program, we either get heads or tails. So basically, I want you to define a class called coin. In this class, we're going to have a method called toss. So every time we call this method, we get a string. So go ahead and try this exercise. You'll see my solution next. So first, I want you to import the random module. So import random. Then let's make a class. Let's call that class coin. In that class, we're going to define a function called toss. So this adds self in parentheses. And in that function, we're going to do random.choice. Then we're going to give it two strings. So heads and tails. So whenever we run this program, we either get tails or heads. So let's store that in a variable called side. And then let's return side. So now let's make an object of this class. So let's do dime. And let's set that to a coin. And then let's do dime.toss. So let's print that on the terminal and run our program. So we get heads. If we run this program again, we get tails. So every time we run it, we get a different result. In this section, I'm going to show you how to work with directories in Python. So here on Python 3 module index, we can see we have a module called pathlib, which provides us an object-oriented file system paths. That basically means it makes it easier for us to work with directories and files. So if you click here, you can see how this module works. You can see a lot of examples. For example, here on the basic use, you can see this is how we can import the path class from the pathlib module. So take a look. From pathlib, import path. Note the naming convention. P is capitalized, that means it's a class. But now, let me quickly show you a few examples to help you get started. So, back in Pycharm, on the top, we write from pathlib, import the path class. Now, we need to create a path object. So, there are basically two ways to do this. We can use an absolute path, or we can use a relative path, which basically means a path that is starting from the current directory. For example, if you want to reference this time directory in our project, we can use the relative path. So we start from the current directory and then we go somewhere else. But absolute paths are different for Mac and Windows. For example, on Windows you can have an absolute path like C drive / program files / Pycharm. So these are directories in C drive. On Windows we use a / to build a path. If you're on Mac, your paths will look a little bit different. So instead of a /, we have a /. Let's say user/local/bin. So these are examples of absolute paths. In this section, we're going to work with the relative path to work with this time directory that we have in our project. Now, if you didn't create this directory earlier, simply right-click on our project and go to New Directory. Okay, so we create a path object. Now, if you don't pass an argument here, this will reference the current directory. So for now, let's add a string, and in this string, let's add a file or a directory. Let's say the time directory. Now this creates a path object, so let's store it here. Now this path object has a few interesting methods. For example, we can check to see if a path exists. This simply returns a boolean, so let's print that on the terminal. There you go, so this path exists. But if we change this to, let's say, time 1 and run our program, you get false. We can also create a new directory. For example, let's change this path to weathers. Now when we run this program, obviously we get false because this path does not exist. But we can create it by using the mkdir method, and that is short for make directory. Let's run our program. So this method returns none, which basically means it does not return any value. Now if you look at the project panel, you can see that here we have a new directory called weathers. We can also delete this directory. So instead of mkdir, we call rmdir, which is short for remove directory. Let's go ahead. Now you can see that directory is gone. We can also find all the files and directories in a given path. So first we change the path to the current directory, and then we call the glob method, so glob. With this method, we can search for all the files and directories in this path. So as the first argument, we need to pass a string that defines the search pattern. We can type a star, and that means all files and directories in the path. We can also optionally add an extension, so to get all of the files, we write star.star. With this pattern, we'll only get the files in the current directory, not the directories. We can also search for all the Python files, so .py, or all the Excel spreadsheets, anything. So let's search for all the Py files in the current directory. Now, when we run our program, we get this generator object. Generator objects are kind of an advanced topic, so we're not going to be taking a look at them in this series. But for now, all you need to know is that we can loop through this generator object. So instead of printing this generator object, let's just iterate over it using a for loop. So for file in the generator object, let's print file. That's it. So when we run our program, there you go. So these are all the Py files in my current directory. This result could be different when you run it based on what Py files you have in this directory. So don't worry if the files you see here are different when you run it. So we can use the glob method to search for files using a pattern. We can also get all of the files and directories in a given path. So we only use one star. So take a look. So we have this time directory. We have notes.txt. This is a file I created earlier just to write notes as part of the exercises. So you're not going to have this file. We also have a bunch of other files and directories. Even though the Python standard library has so many modules for working for different things, it's not really complete. That's why we have this directory called Python Package Index, or PyPi. And in this directory, you can find thousands of packages for doing awesome things. So let's say you want to send text messages in your program. You don't have to build all the functionalities from start. You can simply come to pypi.org and search for SMS. As you can see, there are so many packages that give you this functionality. Of course, not every package is complete. Some of them are still in development. But if you look around, I'm pretty sure you can find what you're looking for. If you learned something, then don't forget to like, share, and subscribe to my channel. I'll see you next time. Bye.